Okay, so I was talking to myself for about 5 minutes in part one at the end. Sorry. Here's the rest of part one that I finished. um, so notice I didn't do anything to this. I was trying to basically prove that cotangent x plus 1 was the same as cosecant x times cosine plus sine. Okay? So by distributing the cosecant through, I got this right-hand side of the equation to be cotangent x plus 1. Cosine over sine is cotangent. 1 over sine times sine is just 1. Okay? Similarly here, I want to try to prove that this side equals this side. Okay? So right now, this side seems a little complicated. Okay? Quite honestly. So I think I'm going to try to get this to work out to be this. Okay, you can start with whichever side you want. So I am going to make this two fractions. Tangent of t over sine t cosine t minus cotangent of t over sine t cosine t. I know that seems odd that I'm almost taking something and making it more complicated by writing one fraction in terms of two. But since they both have the same denominator, I can rewrite them and think of them as two separate fractions, especially since I notice that in the end, I want two separate things subtracted. Okay, does that make sense? I hope. Okay, now tangent, I'm going to write as sine over cosine. I'm just taking identities that we've learned and seeing if it leads me anywhere. Okay, and cotangent I'm going to write as cosine over sine. At least then all I have to deal with are sines and cosines. Sometimes that works out. Okay. I know you guys struggle a little bit with fractions and what this means. If I have, like, let's say I have a third over 4. That's the same as a third times a fourth, which ends up being a 12th, right? I basically do bring this denominator. If there's just one denominator, it's over 1. And when I flip it up, this denominator basically comes into this denominator. Does that make sense? So when I see this fraction divided by this, I can write that as sine t over all three of these multiplied together. Sine t, cosine t, cosine t. Same here. This denominator comes up into the other denominator when I multiply by 1 over that. So I have cosine t over, of course, the sine t that's already there, and then these two. Okay? So I do notice that in this case, the sines cancel, and I have 1 over, I'm going to call this cosine squared, okay? Cosine times cosine. Here the cosines cancel, and I have 1 over sine squared. Another way to say 1 over cosine is secant. So instead of saying 1 over cosine squared, I'll say secant squared. Instead of saying 1 over sine squared, we'll say cosecant squared. And I think that's what we were trying to get to, right? Secant squared minus cosecant squared. Right? So I took the left-hand side and just tried different things. Sometimes what I try doesn't work. And then I have to try something else. Okay? But I know that separating into two separate fractions was a good place to start here because I verified so many trig identities in my life. Okay, so just you start looking at where you're going. I knew I needed two separate things subtracted. So that's what I started with here, writing this as two separate things subtracted. And then rewriting tangent and cotangent as sine and cosine, realizing that I want to get to secant and cosecant. All right. Here, they both look pretty complicated. Not sure which to start with. A lot of times when my denominator, remember multiplying by the conjugate? Okay, I'm kind of thinking I might want to multiply by the conjugate to get rid of this. Here, I'm going to be, if I separate this and write it as two separate things, I notice in the end I don't want two separate things. Anyway, there's many ways to start these. I am just going to choose to multiply this side by 1 plus sine x over 1 plus sine x. Multiplying by the conjugate is always a good idea. Up top, I'm just going to write it that way. 1 plus sine x times cosine x. Okay, I'm multiplying the numerators together. When I multiply the denominators together, I'm obviously going to FOIL, because that's the purpose of multiplying by the conjugate, to get that difference of two squares. 1 times 1 is 1, minus sine x plus sine x, that goes away, minus sine squared x. Okay, now 1 minus sine squared. I'm remembering something about sine squared let's go back to our identities. Okay, sine squared plus cosine squared is 1. So if I would subtract sine squared, another way to think of this is cosine squared equals 1 minus sine squared. Okay, that's another way if I manipulate this equation. Saying that sine squared plus cosine squared equals 1, that means that 1 minus sine squared equals cosine squared. So I might use that little fact. 1 minus sine squared, we just saw, was cosine squared. So I'm just going to rewrite the top the way it is. I didn't really do much with that. But I changed this to cosine squared. Since sine squared plus cosine squared equals 1, 1 minus sine squared is the same as cosine squared. Well, I notice I have a cosine over cosine squared. Just like if I have an x over x squared, that's 1 over x. Okay, you subtract the exponents. It's the same thing in trig. Okay, cosine over cosine squared is 1 over cosine. Okay, I can take one of the ones away here from the bottom. So I end up just with 1 plus sine x over cosine x. And I think that's where I wanted to go. 1 plus sine x over cosine x. Okay, so we were showing that the left side can be turned to the right side by doing valid trig identities. Obviously, in this case, yuck, yuck, yuck. This is a mess, right? Let's get a common denominator and add those together. My common denominator would be 1 minus sine alpha times 1 plus sine alpha. Oh, great. It's happening again. Just out of nowhere, it just starts deciding to, I think there's a ghost in here or something. I don't know. Just all of a sudden tries to be funny. It's not funny. 1 plus sine x. Alpha, sorry. Oh, oh, you're just driving me nuts. Okay, so let's take, in other words, I want that to be my common denominator. So in order for this fraction to have that denominator, 1 minus sine x times 1 plus sine, I'm sorry, I keep saying x. I'm going to pause this and restart. So my common denominator is 1 minus sine alpha times 1 plus sine alpha. So for this fraction to be this denominator, I need to multiply top and bottom by 1 plus sine alpha. 1 times 1 plus sine alpha is 1 plus sine alpha. I'm also going to do that with this fraction. I need the denominator to have both these. It only has 1 plus sine alpha, so I'm going to have to multiply top and bottom by 1 minus sine alpha. Okay, now 1 minus sine times 1 plus sine, that's the difference of two squares. That's 1 minus sine squared alpha. We just did that on the other side. FOIL that together. Ooh, positive, negative. This is just 2. And 1 minus sine alpha, we saw on the 1 minus sine squared alpha, I'm sorry, we just saw on the other side was cosine squared alpha. Remember, since sine squared plus cosine squared, that's one of our identities, that equals 1, then if I subtract sine squared from both sides, I get cosine squared. And 2 divided by cosine squared is the same as 2 times secant squared. That's supposed to be an alpha, not an x. 2 secant squared alpha, that's where I was going. Okay? All right, so remember proofs in geometry, right? That's what we're doing right now. In trig, it's called verifying trig identities, okay? We're going to be given a statement. I just led you through some. And we will need to prove that the statement is true. And that's called verifying trig identities. These hints are on page 203. Okay, obviously learn the fundamental identities. Make sure that you can go fluidly back and forth. We just saw that sine squared plus cosine squared equals 1 is the same as saying sine squared equals 1 minus cosine squared. Okay, we usually start with the more complicated side and get that to the simpler side. Sometimes it's helpful to write all your trig functions into sine and cosine. Sometimes it's not. We use that a couple times. Algebraic things like difference of 2 squares, anything we used to do with algebra, it's the same type thing with trig. So if I see sine squared plus 2 sine plus 1, that would be the same as seeing x squared plus 2x plus 1. Okay? And we can factor that. Usually it's a good idea to find a common denominator if you have 2 fractions added together. Okay. Multiplying by the conjugate. Oh yeah, that's what we did in the last one. Okay, anyway, you can read through these and they're just hints. There's actually multiple ways. I love this section because sometimes I'll have like one trig identity and I'll have my class do it 3 different ways. And they're all correct, as long as you get the left side to equal the right side or the right side to equal the left side. Okay? Caution, this is not solving an equation. When I solve an equation, I'm trying to find the x that will make this thing true. Okay? So I'm assuming that the left side does equal the right side, and that allows me to add 3 to both sides and divide by 2. We're trying to prove that we don't know if they're equal or not. So you cannot add the same term to each side. You can't multiply the same term to each side. Okay, that you do not do that when working with identities. You just start with a side and you don't even do anything to the other side. You just keep manipulating this side until it turns into the other side. Okay? So in this case, I'm going to work with the right side since it's the more complicated one. Okay? I think we did this one already. I'm sorry. This is the one we did, and we worked with the right side. Okay? You didn't know what we were doing back then. We manipulated it until I got it to the left side. Okay? I worked with the right side for that one. Okay? The next one, for this one, I'm going to work with the left side because it's more complicated. Okay? 1 plus cotangent squared. What is 1 plus cotangent squared? Let's go back and look. 1 plus cotangent squared is cosecant squared. So let's try that. So we end up getting tangent squared times cosecant squared. You can see the sine squares cancel. I get 1 over cosine squared. And cosine squared is 1 minus sine squared.